We're going to be solving Leetcode 242 valid anagram. All right, so let's start off by reading the question. Question states, given two strings s and t, return true if t is an anagram of s and false otherwise. All right, that sounds simple enough. So the first question we got to ask ourselves is, what is an anagram? Luckily, Leetcode gives us the definition right here. And it says, an anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once. So in other words, if we have two strings s and t, given t, we can, just by rearranging all the letters, we can form s. All right, so the first question I guess we got to ask ourselves is, how do we know if s and t are two anagrams? Well, the first way that comes to mind is maybe we can sort both of the strings and see, and then if we sort both of the strings and they end up becoming the same string, then we know they're valid anagrams. However, sorting strings gives us a runtime complexity of n log n, and I think we can do a little bit better than that. So what if we instead use a dictionary, and with that dictionary we can count the occurrences of every element in both the strings, and we can count the occurrences of every one of those characters in the strings, and if all the occurrences are the exact same, then we can return true, and if all those occurrences are going to be different, then we can return false. So for example, if we have let's say we have s is equal to bat and t is equal to tab, we're going to have a dictionary mapping from the character to the number of occurrences. So for s, b is going to map to 1, a is going to map to 1, and t is going to map to 1. And for tab, t is going to map to 1, a is going to map to 1, and b is going to map to 1. And since those are going to be the exact same dictionaries, then we're going to return true. However, there is one case that we have to worry about. Let's say, for example, that we have instead bat and tabs. If we're going to, when we're creating our dictionary or updating our dictionary, we're going to iterate through bat, and it's going to be the same. B is 1, A is 1, T is 1. And if we're iterating just through the length of s, then we're going to get the dictionaries are going to be equivalent, even though they're not anagrams of each other. And that's because we're not counting the final character in tabs. So instead there's going to be one edge case, and that's going to be if the length of s is not equal to the length of t. That means that we can definitively not have an anagram. So knowing all that I've said, let's try and solve this question. So first, let's root out the edge case so we don't have to worry about it any longer. So if the length of s is not equal to the length of t, then we're just going to return false because they cannot be anagrams of each other. Now we're going to create our dictionaries to compare the two of them. So we're going to have sdict, or s dictionary, and I'm going to be using a default dict, just because a default dictionary, because it makes it easier in Python to update it respectively. And dictionary is also equal to that. All right, now that we've created our dictionaries, let's iterate through both of the strings and update the dictionaries accordingly. So we're going to iterate through. Then we're going to increment the count of the character in s by 1. And then we're going to increment the character of of t also by 1. And then, now that our dictionaries are completed, we can compare the two to see if they are the same. So we can just return our S dictionary is equal to our T dictionary. And this will return true if they have the same, or if it is a valid anagram, or false if it's different and they're not anagrams of each other. So let's run it and see how it goes. This is all the test cases. Now before I go, I want to first talk about both the runtime and memory complexity. As for the runtime complexity, it's going to be a linear time complexity because we iterate through every element in S&T once. As for the memory complexity, this is going to be bounded by 26 because if we go to the problem description, we see that S&T consists of only lowercase English letters, meaning that the S dictionary is never going to have any more than 26 elements, and same with the T dictionary. So as a result, it's going to have a constant time complexity